Other.
Other, yeah. Go to Java project. Project name is loops. Yeah, don't create new module. The perspective is designed to support Java development. Offers a package explorer. Get more. So in loops project, let us go with one class name. Reverse a number. Let me go with the first program
Okay.
is finding the sum of digits. I will go first of all. Sum of the digits I will go. Then we can reverse and
Sure.
operations.
Yeah.
Sum of the digits. Sum DIZ. Sum DIZ is the name of the program. Sum DIZ. Fine. New method. Okay, fine. Yeah. So directly I will initialize. You can accept from keyboard and those things, nothing. You can add buffer and little adjustments you
Sure.
can do that. But I am straight away going with this, and x is equal to 500, say 76. I will go with this number. Fine. Now the task is to reverse that. Just 1 second. 1 second. Some message
Sure.
I have sent somebody. Okay, fine. So I have initialized x variable. Okay, fine. So I will go with a few uh, initializations. Wait. For some other purpose, I will show you later on. I have to find total also in this context. And n value. Okay, fine. Through keyboard, we are not giving from keyboard. Okay, let me take. Okay, fine. Maybe x. Okay, not taken. Enough. And one more variable is required, dizzy in our program. Let us, in these kind of program, generally we initialize start with 0, total with 0. And then
Okay.
let me go with one more variable, that is digits. So each and every digit you have to separate first of all. So I have taken 576 now.
Yes.
We can cut each and every digit like 6, 7, 5. If you can separate each and every digit, you can store in some place and you can easily add them. So now
Okay.
let us start with a while loop. That is over. Now let us start with while loop. While. So loop initialization is over here itself. Dot is
Yes.
initialized with 0 and x with 576. Couple of initializations we have gone through. Now while that x is greater than 0, then only it will happen. I will explain the entire program. First, let me go through this. DIZ is equal to what is our value? X na? X percentile 10. So I told na, you have to get the reminders every time. Every time the reminder is placed in this variable. Now one famous formula, you know this formula we used somewhere in arrays also. I used numerous occasions. I used this formula like DIZ dis dot dot equals dot plus dis. Otherwise shortcut assignment operator is also welcome. Okay, we used this formula na, in
Okay.
the past also. Dot
Yes.
equals dot plus dis. Sum is equal to
Plus
sum plus
equals. Yes.
array. Yeah. So directly I'm using, instead of a shortcut, directly I have gone with this. Now let me, I forgot putting brace here. Let me add a brace, and then two closings, one more closing is required. Before closing, I have to find the quotient. X is equal to x by 10. X by 10, done. Now the closing brace, while loop is over. Now let me display that. System.out.println. So the total sum of digits, total sum of digits, total sum of the digits. And where is that recorded? In tot. Tot is the variable where we are recording that. Let me run this, then we will see that. You have to get 5 plus 7 plus 6 means how much? 12 plus 6, 18. 18 should be the output. 18 should be the output. Yes. We got it?
Okay.
Fine? Yeah.
Yes.
Now we will understand this. See. So I have initialized it. I want to go with one number and I have gone with x that is equal to 576. I have gone and taught these kind of programs I told now. Taught should be initialized with 0. Then one variable dis I have taken for some purpose. So let us start with while loop. While x is greater than 0, true or false? My number is 576. It is true.
It is true.
It's a positive number, greater than 0, sure. So you got inside. Once you got inside, tell me. I need not speak here. You can talk. See.
Yes.
What is the value obtained for this? What is stored in this? 576. Reminder. What is the reminder? 6. 6 is the reminder.
Yes.
Yes. Next time, whatever we get, we will record that. Leave it. Now here, just let me record for your understandability. Taught. Initially, taught is 0. Very simple. In all these kind of things, you initialize taught 0. I told earlier also for finding total marks obtained by a student, also same formula we used earlier.
Yes.
So same total and average we used that. So here also same formula I am using taught plus, but this time I am adding dis. What is the dis? 6. 6 is added with 0, isn't it? 0 plus 6. Right, like this is equal to 6. So the current value of taught is 6. Don't forget. Now let us go with this statement. X is equal to x by 10. What is the quotient? What is there inside x? Inside x, what is there? 576 is there.
576, yes.
576 is there. So 576 by 10, what is the quotient? 57 is the quotient. Isn't it? 57, obviously. Remainder means right side, last one. Quotient means the other part. That is 57.
Yes.
So 57 is the quotient here. Only let us take decimals. Don't take, let us not take decimals. Take only integer portion. Okay? We should not take decimal portion while getting quotients and all these things in Java.
Yes.
So 57 as a quotient we are getting here, fine. And again, still you are inside the loop. Don't get out of that loop because again 57 is also true. 57 should be tested again every time. So 57 is true.
Yes.
So that again you got inside. Now 57 percentile 10. So what is the remainder this time? 7.
7.
7, absolutely. Yes. Now previous total is 6.
6 plus 7.
Like 6 plus 7, yeah, is equal to 13. Fine. Now it's going to be 5 this time. 5 now. 57 is the previous x value. Now it is going to be 5. 5 is the quotient.
Right.
Yeah, 5.
Yes,
now
yes.
Again, 5 is greater than 0. True. So obviously you will end with 5 here.
Yes.
10 zeros are 0. 5 is the remainder. Fine.
Right.
Now here, one more iteration in the last iteration possibly. So here you are going to add 13 plus 5. Am I right? 13 plus 5 will make 18.
Yes.
We got our number already.
Yes.
And now it will run to 0 this time because 5 divided by 0, 10. 10 zeros are 0. 0 is the quotient. So first time we are encountering with 0. So 0 is going to fail here.
Yes.
So let us come out of the loop so that we can display with this statement. Total sum of the digits is equal to what is there in the grand total? 18.
18.
That will be that's it. This is the trick. Same thing you do one thing, you try with for loop. Okay, you please note that.
Sure.
Of that. You can practice with for loop. Same application. That will be good. Now let us reverse the number. When we are able to find after all sum of the digits, why can't we reverse? That too we can do now without using any method. There is no method. I am not using any reverse method this time. Don't say that I can use reverse because in strings palindrome we use that reverse now. Without using that reverse also we should be able to do. Okay.
Okay.
This time we are going to reverse number unlike a string. Okay. Fine. So let me take yet another application. Inside loops. Let me go with that another one. Loops. Other class. is what is it? Reverse. Reverse this time. Reverse of a number. Add main method. And you can add some user-defined methods. It is up to you. Create object. That story already we have done so many applications. That's why I'm not going into those issues. Just I'm focusing only on loops here.
Sure.
So how to reverse? Let me start with some initialization part. I'm again initializing, taking some number. This time I'm going with n. Int n is equal to, I'll go with 491. 491 is my number this time. Fine.
Okay.
Now, same story, rev. I'm taking one variable. Rev is initialized with 0. Fine. And then des, here also I need des because in the previous program I have done successfully with des. Yes. Now let us start the while loop. While, what should happen? The given number should be greater than 0. Then only the following thing should happen. Yeah, let me start with an opening brace. Now, what is the first formula? Des is equal to n percentile 10. Isn't it? Same formula we used.
Yes.
No? Now, rev is equal to that formula. Rev is equal to rev. Instead of total, we are going to reverse. But little bit difference this formula. Rev into 10. Why I'm writing, you can understand. Wait. We should be able to remember this formula. Little formula, but you can understand later on why I'm using this.
Okay.
And then, as usual, n is equal to, you have to find the quotient, n by 10. Fine. Over. Our while loop is over. Sorry, brace is there already. Now, let us come out of the while loop and let us display that. Whatever the reverse we are getting, let us display that. I want to display like a reverse of the given number is, I cannot do like this here. I have to come out of the loop. Why I will explain later on. Wait. I will do like this. In some batch when I am trying, I got some problem there. Immediately we handled like this.
Okay.
Fine. You can also understand that problem. Wait. So reverse of what is the number? N na? N is the number na?
Yes.
Let us come out of this and let me concatenate that with n, and then reverse of, for example, I have taken 491. So obviously you'll get reverse of 491. Why I'm taking there, you know, here at the time of this statement, you can understand in the previous program, n ended with a 0 or not. Of course, x I have taken in that program.
Yeah.
X ended with a 0 na?
Yeah.
The previous program, you remember this statement, last statement?
Yes.
You ended with a 0 or not? X is equal to 0
Yes.
program. So the time I am leaving that while loop, what is happening here? If I write reverse of n is ending with 0, where can I get original value? I can't get, no.
Yeah.
That's why I'm typing this part here. Still, you can understand once I complete this program. Reverse of n, remaining portion I can write later on, not here. Here I can display. Reverse of n is some space I will give here, because n should be followed with some space. Is what? REV, rev. Got it?
Okay.
This is my logic.
Yeah.
Let me try, let me work. It should work.
But I think it'll be in 2 lines.
Yeah. That I can restrict. What is there?
Yes.
Yeah. But the same logic I tried in C language. Yesterday I was discussing with one of the student. C language, that is different. There is no println and all these things. Some other techniques. Okay, fine, no problem, no issue. After is also some space should be there, no? Yeah. Now it looks good. See. Yeah. Now it looks good, in good shape.
Yes.
Reverse of 491 is 194, right? Now let us study the logic. So you got the message like this, reverse of 491. You got it? But why I'm putting earlier, you know? So once you end up the loop, the n value is going to be 0 at the end.
Right.
We'll try for iterations, you can understand. I hope you understood that point.
Yes, I did.
Exactly. So 491 is greater than 0. True, you got inside. Once you got inside, what is the remainder here? What is the remainder here?
491.
S is equal to 1. Absolutely. Next here. What about here? Rev is initially 0. 0 into 10 is 0. 0 plus des
Plus 1.
is, yeah, 0 plus, I mean, I can write the full-fledged code like 0 into 0 is equal to, sorry, 0 into 0 plus, what is that? 1, 1, yeah.
Yes.
Equal to 1, fine, fine, fine. Next time, n is equal to, obviously you are getting 49, the quotient, 49. It is going to be 49, okay, fine. And then
49 is greater
then again
than
49
0.
is greater than 0, fine. This time you are getting remainder as 9.
Yes.
You understood the technique, how we are
Yes, yes.
separating the digits means we can use percentile operator effectively. So again that 9 will come into picture here, but your rev is 1, the previous rev is 1, you know. So 1 into 10 this time will make 10 plus that latest output
9.
des, that is 9, yeah. So that leads to 90.
19.
10 plus 9, 19, yeah, 19, yeah. 10 plus 9, 19. Next, here we are. So 49, previous one. Now what about this?
This time it's 9.
4, na?
Yeah.
4, we end up with 4 this time, because already
Yes.
49 is the previous occasion that we got right now. And if you divide by 10 using division operator, you end up with a quotient that is 4. 4 is the quotient. 10 4 is 40.
Right.
And 4 is the quotient. Okay, fine. 4 is the quotient. Fine,
So
fine.
4 is
4, true. You got the remainder 0 this time. The leftover is 4. That is the remainder. And now we have to add that. So 19 into 10, that is 190, of course. 19 into 10 plus 4, 194. We got our number.
Yes.
We got our number, Rev. And here you are ending with 0. That's what I'm speaking. This issue.
Yes.
0. We are
Then it would have said reverse of 0
that's
is
right.
194.
If you would have written this here, yeah, you would have got something like reverse of 0 is 194.
Yeah.
That is not correct. That's why we shift a code little bit like that.
Sure.
Now that's how it works. You understood, I think.
Yes.
Same program using for you try. Whatever I am discussing.
Okay.
Because while you may be it may be difficult, that's why easiest one I am giving. You can do that. And then which program shall we do? This technical, this one more question is, I will give one range like 1 to 50 numbers. Among them, if I take some number, all those numbers should be divisible within 1 and 50. Some numbers are there now. For example, if I select 3, some numbers are there in between, some integers are there in between 1 and 50. Those are divisible by 3. 3 ones 3, 3 2 6, 3 3 is 9. So we should be able to pick all such numbers whichever are able to get divided by 3. How to write a program for that? How to write a program for that? We'll see that now.
Sure.
Let us go with another application. Yes, class name. What is it? Divisors are technically what kind of name we can write? Divisible by a given number, na? Divisible. Divisible is the name of the class which I am taking. Fine. That may be appropriate. Fine, we'll go with that class. Okay, fine. Now let us take some limits are there. Upper and lower limits I have to take now. I told lower limit as 1 and upper limit as 10. So that's why I'm going to take int, say lower limit L, LOWER, lower. Int lower is equal to 1 and upper is equal to 50. Within 1 to 50, I have to get that. And then number to be divisible, I should take some number, na? N is equal to 3. Any number, you can take any number. I am taking 3 here.
Okay.
Fine. Now, I will go with for loop this program. You do one thing. Those couple of programs you try with for. This particular
Okay.
program you try with the while. I will go
While.
with for.
Okay.
I will go with for. You try with while. Okay.
Okay.
So that I will go with for this time. For how to take int I is equal to lower. So I is initialized with lower. Then I is less than or equal to upper.
50. Upper, yes.
Yeah, up to 50 na upper. Yeah. And the third expression is going to be every time you are going to increment I value like this.
Yes.
And then come out of that. Just had only one statement in that. I need not put any braces now. Not required.
Yes.
Braces not required. I want to go only with one statement. That is the actual logic. That is if condition. I want to put some if condition here inside that. So what is the condition I am talking about? If I, that number, n.
Mm-hmm.
N is the number, na? Yeah, n is the number, but unfortunately I have gone with I here. Wait. Yeah, I is the number, na, which is coming inside. Initially it is starting
Yes.
from, it should start from, no, I have not given. I is lower, yeah. I is 1, na, first time I is 1. Yes, sir.
Yes.
I is 1.
Yes.
So 1 is tested, true, because upper is 50. You got inside. So once you got inside, I should be divided, na? It should get divided by our number n, that is 3, isn't it? So
Okay.
if all the remainder is going to be 0, then only you can
Oh,
confirm that.
yes.
Then only you can say that it is divisible by 3. Otherwise, how can we say?
Yes.
And if I ask you those which are not divisible by 3, then that also you can do. How?
Yes.
Same code, but not
Instead of equals.
not equal to. That's it.
Yeah.
Double. Instead of double is equal to not equal to. Yes. Now inside that system dot. Yes, I'll go with this. Where is the cursor? Oh. What is it showing? Yeah. So I have to display those numbers, na? Just to display those numbers.
Yes.
I can go with I, isn't it?
Yes.
For instance, first you take one fails, so that you cannot get inside if condition. You have to move to for loop again. I will be 2 this time. 2 is true.
Yes.
2% 2. 0, true. So you display 2. Then what to do? Then again increment. You have to increment I value.
Yes.
Fine. It should work. Let us check this once.
But 2 also fails because it should be divisible by 3.
Sorry. 2 fails. Yeah. I have taken.
Yeah.
I'm thinking 2 instead of 3. Sorry. So 2 divided by 3 fails. But see here, 3 is going to be a success. 3 is going to be a success. 6 is success. See, all are divisible by 3. You can see there.
Yes.
Perfect example for that.
Sure.
And you can be creative and you can do one more thing. I can tell you one more exercise for you is, I have taken only one number. You take 3 and 7. You can take 3 and 7 both.
Okay.
Like that you can do. Those which are means how you are going to do that? You can apply 3 and end means both should happen.
Yes.
3 they should be divided, and with 7 also it should be possible. Logical and or you think about that, both should take place.
Okay.
Both should be true. Means logical and is a perfect combination.
Yes.
Both should happen. Then only you should be able to display. That also you can do, I think. These kind of things you can do. Yeah. You please make a note of that. 3 and 7.
Yes.
Those which are divisible by 3 and 7. This program only divisibles of 3. Only 3 I am taking. You take 3 and 7.
Yes.
And
3 and
means
7.
obviously logical and. And any one among them means you can go with a logical or. That would be fine.
Sure.
Yes.
Yeah.
That is how you can apply this application. And now, next, what to do? Do one thing. Odd numbers. I want to display all the odd numbers within a given range. Same program, but odd numbers I want to get. How do you do that? Let us again. I will go with for loop again. I'll go with for loop. Odd numbers, only odd numbers. Odd. Okay, fine, fine. Yes. Same technique, just like the previous application. What is the logic?
Yes.
You have to take the lower limit, upper limit.
This time we can directly go to R. I mean for, sorry.
For I will go, but before
Inside
that,
for we can do it.
without taking upper and lower limits.
I thought for integer it starts from I is equal to 0 and it should be lesser than whatever limit.
Yeah. What is the question which I told just now? Odd numbers. Odd numbers.
Odd
that
numbers,
we can do.
yes.
That we can do. But I want to use for and if. I want to mix for and if.
Okay.
Yeah. That everybody knows. Yes. See, if I do that already, I told. I think in the beginning, yesterday or day before yesterday. Inside for loop, as increment or decrement operator, you can provide x is equal to x plus 2 or x plus is equal to 2. Yes. That you are saying, okay, fine. But I don't know from where I am going to start. If you start from 0, it is okay. Even numbers can be displayed. If you start from 1, it is okay. Odd numbers, that is left to us here. See, but I am giving numbers like this. See, I am considering numbers from 1 or 0.
Okay.
That's where you get a mistake here. You are going to get some mistakes. See, if I start from into lower is going to be 0. From 0, I want to check. And you have to get odd. How to go? If it is going to be 0, 0 plus 3, 3 plus 3, no, 3 plus 3 is 6 again.
No.
That's why I'm giving lower as 0 and upper as 51. For these kind of things, obviously, I mean 50, up to 50. Okay, fine.
Okay.
Lower limit I am changing, but our trick will not work here. Is it not? Just now, as you said,
okay.
It will not work. Even I plus 3 will also not work. You have to get 5, but you are getting 6, 3 plus 3 next time. That is a problem, playing with these numbers. That's why you can make use of for and inside that if similar to previous technique which you have done. So my number is going to be odd number. That is not required, not required, not required, not required. That's it. That's it. Now let us go with for int I is equal to lower, starting from lower. Okay, and then I is less than or equal to upper, fine, and now here nothing other than I plus plus. Every number you can check, no problem. Every number you can check here. If the condition is I percentage, each and every number should be divided with what? 2. If you divide by 2, it is not equal to 0.
Reminder
if equal to if you write is not equal to 0, is not equal to 0. Remainder is not equal to 0. Then odd number, obviously odd number.
Yes.
Isn't it? So let me display the number system.out. That's it. So here odd numbers means I you can display. If you want, you can make a display here itself at the beginning somewhere here. Odd numbers, all odd numbers between like that. Some message you can display now.
Yes.
You can click control and space bar at a time to you understood this technique. I will tell you, I'll let you know this thing also, small things.
SYSO, yes.
Yes, why? You know that already?
Yes, you had only taught me
told,
about.
Okay, fine.
Yeah.
Not required, but I'm telling you can use that. You can improve your speed.
Yes, but unfortunately it won't work on Mac.
Oh.
Yeah, I tried it because you showed it to me on second day, but it is not working on Mac.
It's not working. Okay.
Yeah.
Okay, fine. Okay, no problem. Wait just a minute. Okay. So what to do here? We have display na message. What is the message? System.out.println. What is that message? What is that?
Odd numbers.
Odd numbers, yeah. Odd numbers between 1 and 50. Sorry, 0 and 50.
Yes.
0 and 50. Every number will be tested whatsoever.
Right.
And if it all find true, then only that will be displayed. Otherwise, skip, move to the next I value, and again test the condition, again get inside. It's happening like that. Let us
Yes.
that's it. Yes, happened. All the odd numbers.
Yeah.
50. Yeah. 1, 3, 5, 7, 9, 11, 13. Yeah, it is working fine.
Yeah.
It's working fine. Great. Okay, it worked. So same program you try with the while if combination you try.
Sure. Yeah. Yeah.
Find the sum of digits of a number. We have done that. Sum of digits. Sum of digits we have done. No.
Yes.
This
Is it
program, what is it?
that?
Sum of,
Yes, yes, we tried
we have
that
done.
576.
18. Yeah,
Yes.
18 we got. Na? Yeah, we have done that also. Count number of digits we have not done. Na? Count number of digits. We will do this.
No.
Counting number of
Okay.
digits. We will do that. Count digits. Count digit. Here itself it is there. Some digit we have done. Count digit we will do this time.
Sure.
Count digit plus count digit. Count digit is the name. Yes. Yes. Now, very similar approach. Count digits. First, we should know some number. Let me take n. N is equal to 674. 13 plus 4. 17, na? Sorry, not that. Count number of digits. 3. If I take 4 digits, 4. 4 should be the output.
3.
4
Yes.
digits are there, na? 4 now. 6, 7,
4.
4, 9.
Yes.
4. Whatever you take, it should be displayed. Number of digits should be
Sure.
displayed. I have taken number, and then for these kind of programs, let us take one variable like count, initialized with 0. Again, I am going with while loop this time. Shall I go with while?
Sure.
While, same technique, no change in technique whatsoever. That's it. While n is greater than 0, fine. Let me open the brace and count should be incremented now. Count is equal to count plus 1. Count equals count plus 1. Otherwise, you can write count plus also you can write. Simple increment operator.
Okay.
Unary operator also you can use, or shortcut assignment operator also you can use.
Sure.
N is equal to n by 10, that old formula we are using. And let me come out of the loop. Once you come out of the loop, let me display the number of digits. So every time you are recording the count value, let me display that. Wait, I will explain this. Wait. Number of digits. Number of digits, shall I write? Yeah. The number of digits is equal to concatenation operator. It should be in count. You are counting number of digits now.
Mm-hmm.
Yeah, let me
Yes.
check this. Then we will discuss about this. Yes, count. Number of digits 4. Perfect. If I
Yes.
add one more 9 I am adding. Let me check. 5. Great. It's working. True. It's working now.
Yes.
Yes. Let us check the logic. So n is such a big value. It's very difficult. 674 is enough. It also works.
Mm-hmm.
74. 3 digits. 3. Yeah. Right.
Yeah.
So 674 is true. You got inside. So once you got into the while loop, immediately can you increase the count value? Means true na. First digit is
Yeah.
there. Yeah, first digit I'm increasing, count to 1. At the
Yes.
end of the first iteration means repetition. Count value will be 1 because
1.
0 plus 1, initially count is 0. 0 plus 1 will make 1, true. Then your 674 will be divided by 10 and you are recording the quotient here, that is
4.
67. Just sorry, what is it?
67.
67.
Yes.
Yeah, exactly. So 67 again true. We got inside. This time our count will become 2, isn't it?
Yes.
Next again 67. Only one more remaining, that is 6. And again true. And again got inside. The count will become 3. That is the last count. Next time it will be 0. No more options left to us. 0 is failing. You got outside. Once you got outside, the number of digits is equal to 3. You end up with 3. That's it.
Okay.
Understood?
Yes.
Understood?
Sure. Yes.
Maybe
Yes.
fast a little bit. You understood or not?
Yes. Yes. I did.
Now let us come to palindrome again here also. Can we do palindrome? Can we try? After doing these many programs, we can try for palindrome. Reversing. Already we have done reverse also, na? If we can see the logic. If we can, already we reversed the program, reversed the integer value, I mean some value we reversed, like 976,
Yes.
679, we have done that. So while we are able to reverse a number, why can't we check whether if it is a going to be a palindrome or not? We can do that if condition. Provided you can store that in a temporary variable. We have done like that in the past also in strings, isn't it?
Yes.
We take all this knowledge into consideration and develop one program. Yeah, another class for checking palindrome, but not string palindrome. I am not checking string here. I am checking
Yes.
purely integer here.
Sure.
Palindrome. Yeah, palindrome. Main method. Okay, fine. Done. Same, just like reverse logic, I can do. So how to write the? We have to take some value, na? First of all.
Yes.
Int n. N is the original number. That is whatever I am doing, you can accept from keyboard also. No problem, because
Yes.
the only couple of more steps will be increased, like importing IO package, throws IO exception, and then
Buffered
for
reader.
that lengthy statement, and int n is parsing is required. You know that.
Parse. Yes.
Yeah.
Yes.
Nothing great. Don't forget that. Now, what else? What other variables are required? Temp is required, na, for us, temporary.
Yes.
Because the original one is going to lose its shape, you know. In the previous program also, n becoming 0, you only said. If we do like that, n will become 0, you said, na? Same story. That's why I'm requiring the original value inside a variable by name temp, temporary variable, but it is going to be original later on. And then rev I have to take reverse. You have to reverse for that matter.
Yes.
And I'm initializing that
0.
with 0. Loop initialization is over, and one diz I'm taking. Diz for same purpose as we have taken earlier in the reverse program. Now let me go with the logic while n is greater than 0. Same logic, no difference. And inside that, what to do? Diz is equal to
Reminder.
n percentile 10 will work for us. Followed with that formula, rev is equal to rev into 10 plus that
plus
is a reminder, diz is the reminder. Then what else? N is equal by 10. We can
n by 10.
And then if condition comes into picture. So shall I write if condition inside while or outside while? We have to write inside while only, isn't it?
Yes.
No. Wait. No, not here. You have to come out of while loop now. So first you reverse the number, then we have to come out of the while loop, isn't it?
Yes.
Now what we have done? Whatever.
Reverse.
So the reverse is there. Now you should come out of while loop, isn't it? We have to come out of while loop clearly. Now once we came out of while loop, now we apply if condition. If what is the logic? Temp is equal to rev. Before that, we have to equate that n and temp. Na? N is equal to, sorry, temp is n. That is required or not?
Yes.
Because n is changing its shape every time. 3 iterations are
Right.
happening because our digits are 3. So 3 times you are iterating, means repeating the loop, obviously ending with 0 for n value. But originality
Right.
is lost as far as n is concerned. That's why we kept the original shape of n in temp. And now the temp is nothing
Sure.
but original value, obviously, and that temp you are comparing with rev by using a comparison operator and of course if condition. Now if is true, then you have to display. You have to display. It is a palindrome. The number is a palindrome.
Palindrome. Yes.
The given. I want to display the number. What to do? The given. Shall I go with n or temp? N or temp? Temp. No more. No more n. N is last. N is 0, na?
Yes.
So the given.
Yeah.
Yeah. The given temp is the given temp. The given. I mean the given number is the given so and so number. The given the given number. I should write number. That looks good. The given number. The given number 785 is not a palindrome, of course. I have gone with 785, of course. Is I will change the number later on. Is a palindrome if it is palindrome.
Okay.
Else not a palindrome. That's it. Let me copy this statement. Else what? Not a palindrome. Even
Not a palindrome.
is not a palindrome. That's it. That's it. Is this everything matching? The given number is not a palindrome. True, it is true. If I end with 7,
Yes.
now it is a palindrome.
Yes.
Palindrome. You are getting same thing. Yes, the given number is a palindrome. I think you understood this.
Okay.
Up to here
Yes.
is 787.
Yeah. Reverse.
And then while loop, it is true. First time it is true. 787 true. You got inside. And here you are retrieving what? Des. What is there inside des? First iteration. 7 is stored.
7.
And rev. What is there inside that? Rev is equal to rev. Rev is 0 na initially. 0 into 10. 0 into
0 plus 7.
0 into 10 plus, what is that?
7.
7, yeah. That is equal to 7. 7, fine. Next time, n is ending with 787, na? 7,
Yes. 78.
78.
Yeah.
Next 78 true, got inside, you are ending with 8 here. 8, na? And then rev, what is rev? 7. 7 into
7 plus 8.
7 into 10, na? Don't forget 10.
Oh, yeah. 70 plus 8.
7 into 10, because you are reversing, you are not finding sum of digits. Sum of digits is different. Sum is equal to sum plus.
Right.
So 7 into 10 plus what? 8.
8.
Exactly. 78 you are getting here.
Mm-hmm.
Then 7.
Divided by 10 is
Next time
7.
7 is the quotient. Fine. 7 is also true. You got inside, and again you are ending with 7 here. Okay. And then that should be added, means you are going to multiply this. Okay, here the output is 78. I forgot writing here. 78, fine. So 78 into 10, that is 780. 78 into 10 plus 7. 787. You are getting that? 7, 8.
Yes.
Done. Now it will be no more. It is 0. It is 0 now. N is 0 last time. So no more iteration possible.
Yeah.
Coming out of that. So if temp is initially 787 is equal to rev. Rev is the final rev. You can see there. In comment, I have commented 787 na final rev.
Yes.
Middle statement. This
Yeah. Yeah.
expression. You can call this also this expression also. These are all expressions or statements. So 787. So the given number, that is 787, is a palindrome. That's it.
Yes.
works. That's how it works.
Okay.
Three more programs we can do. One more I can tell you. Same 1 to 50 numbers are there.
Okay.
Either with the 2 or 3 it should be divided. Means what?
Okay.
Either with the 2 or 3. Shall I do, or you can do that?
That is the homework that is
That is both. In that case, I have told both should be applicable.
given.
Here I am saying,
Divided by 3 and 7.
either by 3. They're both 3 and 7. End 7. Logical and.
Okay. Okay.
But here I am saying I am giving two options. Either by 2 or by 3. Either
Okay.
or. There and both should be true there. Both means
Okay.
logical and. Here either this or that. Any one should be true. Either this or that.
Okay.
Able to understand? Either this or that. Means
Yeah.
logical or you have to apply.
Yes.
I will give inside if condition. I will give, if you want, you can take that logic. If I is the number, for example, I you take na inside for loop. If I percentile 2 is not equal to 0 and I percentage 3 is not equal to 0. Is it right?
Okay.
In between, what is the operator?
And
Any one, either this, either 2 or 3, I am saying. And or which works fine. Either 2 or 3 it should be. Any one should be true. Any one means unnecessary. It is not correct. Both should be. Both means and only correct.
and yeah.
And already we have done that. Not required again. And sum of 1 to n natural numbers. Can you do? Sum of first 1 to n natural numbers.
Okay.
Using arrays we have done using something like this. This formula you can take. Sum is equal to sum plus, you can take array AR of 0. We have done na.
Sure.
Sum
I will
of
try.
n, you try that also. Sum of n natural numbers also you can try. Okay.
Okay.
Sum of natural numbers, and then what else we can do? And identity. Have you heard about identity matrix? Identity matrix
No.
means 1 0 0 0 1 0 0 0 1. You please write whatever I am saying in a matrix form.
Okay.
1 0 0 1 0 0. Then
Okay.
0 1 0 and then 0 0 1.
Okay.
Can you try to write a program on this? I want that shape.
Sure.
I will do. Wait, I will do. So what is the logic? What kind of logic can you observe? So these kind of programs I told you earlier, immediately you have to draw a table so that you can locate the memory locations. So what could be the logic? Whenever I is equal to Z, isn't it? You have to take for inside for. If I is equal to Z, what is the logic? Both I value, J value true. You see the diagonal elements. When the diagonal elements are 1, tell me. I is equal to Z na?
1 1 1.
First, what is the first position? 0 by 0, 0 by 1, 0 by 2. Next.
Hello.
Yeah. Hello. Yes. Can you hear me? Can you hear me? Hello. Is it audible?
Hello. Yes,
Hello,
now
yes.
it is audible.
Yeah. See, you take the positions like this. First row, 0 by 0, 0 by 1, 0 by 2. Second row, 1 by 0, 1 by 1, 1 by
1
2.
by 1.
Third row, 2 by 0, 2 by 1, 2 by 2. Got it?
Yes.
Now when I
Yes.
is equal to J, tell me. When I is becoming equal to J? First 0 by 0. I is equal to J,
Right.
na? Next,
Yes.
next 1 by 1 is there.
Yeah, and then 1 by 1.
1 by 1
Yes.
is there. Then last one.
And 2 by 2.
2 by
Oh,
2.
yes.
That's why. Take for inside for. And inside the inner for, I am telling, if I is equal to J, if I is equal to J, what to do? Display 1.
Okay.
Display that 1 you can display. Else don't display anything. 0. Else display 0. Else display 0. Shall I do that? Shall I do?
Sure.
Any mistake in this? It is showing mistake here. What happened? some mistake. What happened here? Not checked this one.
Uh,
Previously I checked.
I think it's just semicolon
Where? Comments,
after.
comment. I missed comment here. Comment I missed. No, that's it.
Yeah.
Yeah, I will keep a record of these programs so that. Yeah, now we are getting the given number is 7 is a palindrome.
Yes.
So now let us go with that. That is called as identity matrix. Please remember, if you get
Sure.
such shapes, it is called as an identity matrix. So the shape
Okay.
is I is equal to Z, means 1 0 0 0 1 0 0 0 1. That particular shape
One.
will be considered as identity matrix.
Okay.
Class is identity. Okay, fine. Finish. Yes. Yes. So you are supposed to take uh, anything required in this program? Any number required to be accepted? No. Directly, shall I go with for loop? We can
Sure.
go with for loop, na? For within bracket int I is equal to 0, I is less than or equal to less than, I is less than 3, 3 by 3 matrix I am taking, 3 by 3.
Yes.
And the other one is I plus plus, every iteration. Same thing for J also, we have to do. Control C, Control V, fine. Let me make this as J.
Sure.
Here also J, and here also J. Okay, fine. So inner loop is also done. Now braces are required. In that, what is the statement? Which statement I can go with? Brace is not required. I think. Wait, only one statement I have to write. Na? Brace may not be required. Wait, is not required, certainly. But outer one, brace is required, sure, because we have display matrix notation na, for that matter.
Mm.
Now here, what I want to do is only one statement will be there. Even we will check if brace is required, we will go otherwise. Because SOPL is required at some point of time. SOPL is required, brace is required, sure. So here, what is the logic? If condition, na? If
Mm-hmm.
I double is equal to J, then what should happen? Then what should happen? System dot
It should display one.
no ln please. Huh?
Sure.
Not
Yeah.
print only. Now we have to display one simple digit one.
Yes.
One should be displayed. I'll put in double quotes. One should be displayed. Else zeros, all zeros. Else you should be able to display 0 else. 0. Fine. After this, these are the statements present inside for loop. So better I go with braces. That is better. Wait. This is all part of that. Then once you come out, normal empty SYSO you have to write now.
Mm-hmm.
Empty, because to get the new line. Let me try this. Once we got, we can understand this. No. What is the wrong? What is the mistake? What is the mistake?
I think one other bracket is missing.
It's showing here. Yeah, one more is required now for main method to close, class to close, and all these things. Yeah, now it is done. Wait. For loop 1 2, yeah, it is done. Pairs two pairs are there. Yeah, but still mistake. No, but shape is not correct, isn't it? So
Yeah.
where to place this? Wait.
Else also we have put ln 0.
Exactly. There we went wrong. LN business will come into picture. Yes. Now we'll run this. Yes, we got a good shape,
Yeah.
but better we
Yes.
give you some tab space also.
Space. Yes.
So concatenate that and provide some tab space. Fine, 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 fine. Here also, no?
Yeah.
Yes, exactly. Yes. Done. Now we'll get perfect identity matrix. Yes. Yes. Got it?
Yes. Okay.
You
Yes.
can really play with these kind of programs. If I want
Sure.
something like here I want one, next second row I want two, third row I want three, something like that. How to do this?
Mm-hmm.
You start your loop accordingly. I can get like this. I is equal to 1, I is less than or equal to 3. Similarly, j is equal to 1, j is less than or equal to 3. Inside this same logic, if I is equal to j, then only you have to display. Here you can write, in place of 1, you can write I or j, anything you can write.
Sure.
Understood? Yeah,
Yes.
I think you understood.
Yes. Yes.
Yeah, you can try that also. That also you can
Sure.
do. And then uh, any other logics? Almost all. And factorial of a number I have to tell. For that we have to go with methods calling, I mean a function calling another function. Function calling itself, as a matter of fact, function calling itself is known as recursion. Recursion concept I have to explain. What is the time? Shall I go on tomorrow remaining things?
Sure. Yes.
Because these are all logical programs now.
Yeah.
You need to just revise and you have to do
Practice.
these things.
Yes.
Yeah, yeah, you have to
Sure.
practice these things. Shall I close the session with this for today?
Yes. Yes. Sure, sir. Thank you.